Okay, hi. Can everyone hear me? Can anybody hear me? Yeah, okay. So I'll just start. So I'm by Shuin and I go to Troy and I'm a sophomore and I'll be your teacher for today. So today we'll start lesson 8, which is LISP. Okay, so just an overview. What we're going to go over today is what is a LISP, the syntax of LISP, basic functions, list functions, arithmetic functions, and user-defined functions. And then we'll do some practice. Okay. So what is Lisp? Lisp is one of the simplest computer languages in terms of syntax and semantics, and one of the most powerful, and it was developed as a different way to think about programming than languages such as Python, C++, and Java. Okay, so the syntax of Lisp is that one constructs a list by enumerating elements inside a pair of parentheses. For example, here's a list with 4 elements. So here we can see the main parentheses. So there's one element here. This whole thing with a parentheses on it is the second element. Hello is the third element. And 821 is the fourth element. And then inside this parentheses, there's also 3 elements of this is easy. So the elements are basically separated by spaces. And as we can see, all statements in Lisp are function calls with the following syntax: function argument 1, argument 2, argument 3, and so on. And to evaluate a list statement, each of the arguments are evaluated and then the function is invoked within the arguments. Okay, so to continue, an example of the syntax is mult add 2, 3, and add 1, 4, 2 will have a value of 35, because here we do add 2, 3 first, because when we're multiplying this parentheses by this parentheses, so 2, 3 is 5, and add 1, 4, 2 is 7, so mult 5 times 7, which is 35. So all statements return a value, and it's either an atom or a list. Okay, so let's go over some basic functions. So first we see the functions set and setQ. So assigning a value to a variable is used with the function set, and setQ is the same as set, but it causes this to act as if the first argument was quoted. So here's a chart, and we can see as an example, first for set, set quotation mark A, mult 2, 3, it'll be, the value is 6, and what this is doing is putting the value of 6 inside of 8. And then if we add another parentheses, when we put it in set, it will turn it into A is a list with 3 elements, mult 2, 3. And then if we do set B and then another quotation mark A, so basically what the quotation mark is doing is we take the literal value. So then it'll be A. B is an value with the value, B is an atom with the value of the character A, and then set CA, where because there's no quotation mark, we set it to the actual value of A, and we see the actual value of A here is mult 2, 3, so then we're setting C to be mult 2, 3. And set Q, X add 3 mult 2, 5 will be 13, because we see mult 2, 5 is 10, we evaluate it, because there's no quotation mark, we're going to evaluate, so mult 2, 5 is 10, and then adding 3 and 10 is 13, so we're setting EX to be 13. And then setting Q vowels, when there's a quotation mark, we just take the literal list, so then vowels will be set to A, E, I, O, U. Okay. So 2 other basic functions we have are eval and atom. So the function eval returns the value of its argument after it has been evaluated, and the function atom can be used to determine whether an item is an atom or a list. So if we do set Q P, add 1, 2, 3, 4, this is talking about the previous set Q. We're setting P to be the value of a list, this list, because there's a quotation mark. And then when we use the function atom, it will be true because atom is an atom. It's just it's atom P. But if we do atom P without the parentheses, it'll be nil because P is not quoted, so it is the value of the 5-element list. And what an atom is, it's just one like single value. It's not a list. So if it was like eval P, then it will return 10 because the argument to eval is the value of P. The value of P is 10. Okay. So list functions. List functions, so we see car X returns the first item of the list X. X must be a list or the error will return, and CDR returns the list without its first element. And then we can see that we can combine them. And when we combine them, we can write like CAADDAR, which will be equal to car, CDR, car, because we see car, CDR, car. So it's just a shorthand way of notation. And then we have cons in reverse. So the function cons takes two arguments, of which the second must be a list, and then it returns a list which is composed by placing the first argument as the first element in the second argument's list. And the function reverse returns the list in which the arguments are in reverse order. So here are the functions put to use. So for example, car, this is a list, quotation, will return this because car returns the first value. And then CDR returns is a list because it returns everything besides the first value. And then cons, quotation red, white, blue, will return red, white, blue because as we can, when we go back, we look, it combines them together. Basically, it puts one element into the other list. So cons red, white, blue will return red, white, blue. And then set QZ cons red, white, blue, CDR, this is a list. So we evaluate by parentheses, right? So CDR, this is a list. It returns the everything besides the first, so is a list. And then we're combining reds, white, blue with is a list. And reds, white, blue is going to be like acts basically as an atom because there's a quotation. So then we see there's parentheses. So it's red, white, blue is a list. And we're setting that to be equal to Z. And then when we reverse Z, we are basically reversing, like putting the last value first. So we see list goes here, list A is, and red, white, and blue is not reversed themselves because they count as one item in a list. So then they will just be last. Yeah, car doesn't have a parentheses because it returns an atom. If there's a parentheses, it's a list. Okay, and then CDDARZ is, so first we do car, and then we do CDR of it, and then we do CDR, right? So when we do car, it will be returning the first value, which is red, white, blue, I think. Yeah, red, white, blue. And then it will take the last two values because we're not adding the first, because CDR takes the last, everything besides the first, so it'll be white, blue, and then it'll take blue. So then the CDDARZ is blue. Okay, so next, user-defined functions. So LISP also allows us to create our own functions using the definition defined function. So what do you mean by so they add on to each other? Okay. So for example, here, I see that they define what argument, it will be equal to cons argument reverse CDR argument. So basically what they're doing is they're defining their own function. So when they call what X, for example, they're going to be doing this evaluation. Yeah, blue is isolated. Okay. So let's keep going to some arithmetic functions. So these arithmetic functions are pretty self-explanatory. Adding is adding them, subtracting is subtracting, multiplying is multiplying, and here's just a table. And some different ones are EQ, AB is it returns true if they're equal and false otherwise. POS, it returns if it's A is positive, and neg returns if it's negative. So here we can see that they're just using like simple arithmetic operations. Okay, let's continue. Okay, so practice. So I'll do this one with you guys. So we're evaluating the LISP expression CAR, CDR of 0, 1, 3, 2, 1, 2, 4, 1, 3, 2. So what does CDR? So first we have to go inside the parentheses. So we're evaluating CDR first. So then CDR returns everything besides the first value. And remember that each like list itself acts as basically one atom. So we see there's 4 atoms. And then we want to find CDR is taking everything besides the first atom. So then this will be equal to 3, 2, 1, 2, 4, 1, 3, 2. And then CAR takes the first value of this, what we found here. So then it will be 3, 2, 1. So the answer to this is 3, 2, 1. Okay, and then let's continue. Okay. So let me clear this. Okay. So next, let's try this LISP expression. So we see that this is basically equal to, I can type it out. It's a shorthand notation for CAR of CAR, CDR, CDR of this like expression. Okay, so first we're going to evaluate CDR, right? So when we evaluate CDR, we're taking everything besides the first element of the list. So then we see we have one atom here, another atom here, and one last atom here. Okay, so then we're taking everything besides the first element. So then we remove this. So now it'll be, we finished this expression. So we're going to do CDR again. So we're taking everything besides the first element of this. So then we're removing this, right? So we're just keeping this last list. So then we're taking CAR of this, which we're taking the first element of this. So then we see that inside this list of 5, 4, 3, 2, we're taking the first, we have an element right here and an element right here, right? Because this is where the parentheses end. And then we take the first element, so we're taking 5, 4. And then CAR again, we're taking the first element of 5, 4, so it'll be 5. Does 3, 2, 1 happen? What do you 3, 2? There's no 3, 2, 1. I think you might have read it wrong. It's 3, 2 parentheses. I might have written it like a little bit similar to 1. So let's continue to the next question. Okay, so why don't you guys try this and type it in the chat? Yeah, 3, 2, 1 will have parentheses around it because it's a list. Okay, so let's move on to this question. Can you guys try this question? Okay, so someone got F, so let's see if they're right. D, okay, so there's a couple of answers. So let's try this problem. Okay. So we first evaluate CDR, right, of this. So let's look at the elements in this list. So the first step of the problem would be to finding like each separate element because it's a bit confusing with all the parentheses. So first we see one element here, A, and then we see a parentheses. So we know the next element is going to be a list. So then we see there's a B and then another parentheses. So then we know there's going to be two more parentheses at least before this atom ends. So then we see that here, this is another element, and then EFG is another element. So we have three atoms in this list. So CDR is taking everything besides the first. So basically what this is returning is the same thing without A. So then now we're going to move on to CDR again. So we're taking everything besides the first element. So now we have a 2-element list. So we will return EFG. And then we're taking everything beside for CAR, we're taking the first element of the list. So I think it will be E. Yeah. This one will be E. So once we reach E, if there's a CDR again, it will return the same value because it's basically a list with one value. Okay. Let's keep going. Can you guys try this problem? Oh, sorry. Jenny has a question on why is A is a separate element but not B, C, D. Okay, so A is a separate element because there's no parentheses around it, but when we see B, C, D, they're together in one parenthesis, so we can't separate it out. If it was separated out, it would be like this. Let me annotate. It would be like this, and then there'd be no parentheses here. Then this would be an element with 4 atoms, basically. So do you understand now? Okay, so sorry. Let's move on to this next question. Okay, so there are a couple of different answers, so let me go over it. Okay, so first let's basically determine the atoms in this list. So we have B, C, D, E, F, G parentheses around each one. So this one is going to be an atom because what I would do is I look at the first parentheses or whenever in a parentheses appears, and then we know that at the end of it, there will have to be at least another closing parentheses so that I find the next closing parentheses and then I see that, okay, this is one atom. And then we see another parentheses here, and then we find another closing parentheses. So this is a second atom, and this is the third atom. Okay. And then so we're doing CAR, so we're returning the first element of this list. So then it'll be BCD. And CDR is returning everything besides the first element. So then this will actually be a list that's C space D. Are there any questions? Okay, no questions. Okay, let's continue. Okay, so why don't you guys try this problem? Reverse is, yeah, flipping the list backwards.
没有那个没登录微信是吧？登录微信比较好一点，不然不好截屏。登我的吧。我电话呢？
Multiple people got E, so let's see it and see if that's right. Okay. So first, let's like find the elements in this list. So we see a parentheses here. So we know we have to have at least one closing parentheses in order to make sure that this is one atom. So let's keep going. There's an A and there's another parentheses. So we know we need two now. So then we continue B, C, and there's two parentheses. So then we know, okay, this is one item. This is an atom. This is the second atom. This is a third atom. And then we see a parentheses. So we know we'll need one more. There's another parentheses, another one. So we'll need 4 closing parentheses for this list or atom, basically. 2, 3, 4. So then we have 1, 2, 3, 4 elements in this list. So CDR will return everything besides the first element, right? So we remove all of this and then we're reversing it. But remember, it reverses the atoms, not the stuff inside of. And since this counts as one atom, we don't reverse this. We're putting this in the front and then D and then C. So then what the new value will be of this is E, D, A, C, B, E, D, C. Okay. And then we are doing car. So then car is saying the first element. So then again, we have an element here, an element here, and an element here. So we're taking this element. And now we're on CDR. So we're turning everything besides the first element. So let's enumerate this one. So we see that in this list, we have an E on its own. And we encounter a parentheses. So then we know that we need to have one closing parentheses at least. And then we encounter another one. So there's 3. So then basically what this is an E and then it's a D, A, C, B, E. Okay. And then CDR is returning everything besides the first element. So we're going to, remove the E. And then CAR is returning the first element of this list. And that is clearly D. So the answer will be D. I see. Does everybody understand? Oh, DA and CB split because they were already split before, like at the beginning here. There's like the DA and the CB here were split. Are there any questions? Oh, why do they switch? Oh, sorry, they didn't switch. Wait, they didn't switch order. They're right here. There's a DA and CB. Yeah, it is one element total. I'm confused. Yeah, here there is the DA and then the CB. They stayed the same. Like I'll show you right here. It was this one element was E, D, A, C, B, E. And when we reversed it, the E, D, A, C, B they stayed the same here. If there's one big element left, then car would return. So if there's one big element left, then CR would return. Jenny, can you elaborate on your question?
Wait, can I like unmute? Like,
Yeah.
can I? So like, because like the big element in the parentheses left was like DA after the CDR step. The only like two elements left basically were DA, and then that's why the answer is D.
Oh, after the CDR step, there was
Yeah,
actually a larger element. It was the DACBE because we were just taking away the E in the CDR step.
but then is like DA, so because like why did the CAR return like only D and not like the entire thing? Because isn't it one element? So like there's nothing left to like split.
Oh, because the CAR returns the first element of the list. And then when we return the CDR, the new list becomes like the new list is like this is an atom, although we count it as an atom, it's actually a list. But when we like enumerate it, it's technically an atom. But after we return CDR and it's this entire list, it will just become one, like it'll become a list. And then the D will become the new atom, and the A is an atom, and the CBE is an atom.
So like after the CDR step, like the atom basically became like a list, and like each one basically became like an individual like thing. So then CAR was like the first like thing.
Yeah.
Okay.
Okay, so you have Donald has a question. So during a reverse, even elements in a list swap. During a reverse, the elements don't swap. Can you? Yeah. Here, when we did the reverse, we had the CD, ED. This was one item in a list. So then this one just moved to the front of the list. And then the D became the middle, and then the C became the end. There was no switching order between the lists because it's technically like an atom right now. Okay. So are there any more questions or are we all good? No questions? Okay. So let's continue. Okay. Try this problem. Okay, so some people got 2, so let's try and see they're right. Okay. So again, the first step of this is finding the elements in this list. So first we see that the first element is 1 because there's no parentheses around it besides this one, but this one is counting the whole list. So the first element will be 1. And then we see that there's a parentheses here, so we know we'll need at least 1 closing parentheses to finish off this atom. And then so we have a 2 and then another parenthesis, so we know we'll need another one. At least we'll need 2 parentheses to finish this list, and then we see another one. So then now we have 1 parentheses, and then we see another opening, so then we need another closed one, so it's here, here. So then we know that this is an atom, and then 8 is the last atom on the list. So first we're returning CDR, and CDR is returning everything besides the first element. So then it will be taking out the 1, and then it will be these 2 elements. And going back to like Jenny's question, this one will still count as an atom because there's an 8 after it. So then when we do CAR, we're returning the first element of a list with 2 atoms. So it'll be the first atom, this one. But then here, it will turn into a list of 2, 3, 4, 5, 6, 7. So then CDR of this one. So let's enumerate the list. We have 1 atom here, an atom here, an atom here, and an atom here. And CDR is returning everything besides the first one. So then it will be 3, 4, 5, 6, 7. And then CDR will be 3, 4. Because we're returning the first element of this list. And we have 3 atoms of this list. 3, 4 is an atom, 5, 6 is an atom, and 7 is an atom. Are there any questions?
Are like the two, in parentheses 3, 4, like 5, 6, 7, are they, can we think of them as like sub things of the overall like 1, 2, 3, 4, 5, 6, 7, 8 like string, and then like,
What do you mean by that? Sorry.
because what do, because like before for like the CDR stuff, like 2, 3, 4, 5, 6, 7 were like all like one like big element, but then after when they're the only ones left, they get like split into like
Yeah.
sections. So like they're like sub things.
Yeah, you can think of it like that.
Okay.
It's yeah.
Okay.
It's just we have to make like keep track, because sometimes like when you add another, like when there's an 8 behind it, then it will not, this won't, the 3, 4, and 5, 6 are not individual elements. They're only individual elements when this atom becomes a list.
Okay.
Yeah. Okay, so are there any other questions? Okay, no questions. Okay, let's continue. Can you try this problem? Oh, sorry, I forgot. I got disconnected. Can you guys try this problem? And this problem is a little different because there is like arithmetic operations instead of the list operations. Sub is subtraction, and there are a couple different answers like 16, 24, and 52. So there might be an issue with like parentheses. So let's try this problem and I'll try to help clear up the different answers. Okay, so we have many elements. So first, let's just go from left to right. So we see we have an add. So we know with an add, we can have any number of elements. So let's just look at the parentheses next. So we see that we're gonna add this one with this one, with this one, with this one. Does anybody have any questions about this? So we're adding these 4 elements. Does everybody understand why we're adding 4 elements first? Yeah. I'm assuming yeah. So then let's continue. So let's just evaluate each different atom. Again, it's simple, but instead of just taking the first element, we actually have to do a little bit of math. So we're subtracting 1 from 4. So this one is going to be 3. We're adding 3 plus something. And then exponent is 2 to the 4th power. So this one will be 16. And then we're adding 3 times 5, which is 15. Sorry, this looks like an 18. And then we're adding this. So then we have to evaluate this one a little bit differently because there's also atoms inside of this atom, even though it's technically not an atom. So we have exponent, we're multiplying this one by this one. So it's 3 to the 2nd, which is 9. And we're subtracting 4 from 2, so it's -2. So this one will be -18. So then it'll be 3 plus 6 plus 15 minus 18. So it's 31, 34 minus 18, which is 16. So are there any questions about this? In order to make it clear, I can help type it out. We can, if this is a little bit confusing to you, you can also turn it into a more like a mathematical expression that we're more used to. So it would be basically 4 minus 1 plus 2 to the 4th plus 3 times 5 plus, and we have to be careful here, we're multiplying these 2 atoms, so then it will be plus parentheses 3 to the power of 2 times 2 minus 4. So this could be a little bit more, this could be, if you don't understand, just turning it into a mathematical expression. Okay, so let's continue. I want you guys to try this problem. Talking, can you mute, please? Here. If this problem is a little bit confusing, basically what they're doing is they're putting this value into this function. I think it's just too long, so they wrote it in 2 lines. Okay, so there are a couple different answers, and I think I gave enough time, so let's try this problem. Okay. So we see here that there's a very long list. So now that we're used to this problem, I think we should know by now that we're going to enumerate the list first, basically, and like find the atoms. So we see this is an atom, this is an atom, this is an atom, this is an atom. These are individual atoms. There's this huge atom. Okay, so first we do CDR. So CDR, we're taking everything besides the first atom. So we remove this, and the CDR is gone. And then we're taking CDR again, so we're removing this. And then we're taking CDR again, so we're removing this. And now we're reversing it. So when we reverse it again, we need to make sure we're careful. And we're only reversing the atoms. Although this atom is technically a list itself, we're keeping the same order of this. We're just reversing the order of the like atoms in this list. So then this one will be 1, 2, 3, 4, 1. And then 3, 2, and then 2, 3, 1. Okay. And then we will be doing car of this. So then car is taking the first element, right? So then it will be these. So again, the elements are this. So we're taking the first element, so we take all of this away. And then CDR, this element this atom, although it was an atom before, is becoming an element, like a list now. So we have to find each atom. So then, wait, sorry. We did this one, and then we did this one, and then we're doing CAR again. So here we see that there are 2 atoms here. So we're taking the first one, and we're taking this one off, and then we're doing CDR. So everything besides the first element. And again, although this was an atom before, it becomes a new list. So then we have to find each atom. So this is an atom, this is an atom, and this is an atom. And we're taking everything besides the first element. So we're removing 1. And then we're taking the first element of this, which is 2, 3. So I see many of you guys in the chat got it right. So good job. Okay, let's keep going. Sorry. Okay, let's continue. Try this problem. Okay, so I see there are a couple answers in the chat. So you guys, okay, so let's try. Oh, sorry. Okay, we were on this problem. Okay. So let's try this one. So we should be familiar with the routine by now. We're finding the elements in the list. So then we have this element, this element and this last element. So we have 4 elements. So first we're taking CDR, which is everything besides the first element. So then this will be gone. And then we're reversing it. And remember to keep that list as an atom. So then it'll be F6G. That's the first atom of this list, and then D45. And then we have C. Okay. Oh, there should be another. Sorry, there should be another parentheses up here. This. Okay. So now we take CAR, the first element of the list. So then we'll have EF6G. This one will be the first element. So this will be the what we have to work with now. And then since this, although it was an atom before, it becomes a list now, we have to find the atoms again. So we have E and F6 and G. And then we're taking away the first element in CDR, right? So then we'll have F6G, which I see many of you in the chat got right. Yeah. Okay. Some people who got F6, I think you're a little confused, maybe. Remember that we have to take everything besides the first element. Okay. Let's keep going. Try this one. Okay. So I see there. Fine. Okay. So I think some people got somebody got -1, some got 9. So there are a couple different answers. So let's try this. Okay, so I'll try another method, which is writing it out as a mathematical expression and then evaluating that one. So then we see we're adding many values together. So first we're adding -2 plus, and then we see there's a huge parentheses over here. So then we are doing 7 minus 2 plus 2 to the 4 plus 12 2 to the 4 plus 12 divided by 4 plus -1 times 3 times 5. So are there any questions on how I got this expression? Oh, okay. So then we'll evaluate this expression with PEMDAS. So then it'll be 5 plus 16 plus 3 minus 15, which is equal to 9, which is like what most people in the chat got. So good job. Okay, so then let's keep going. Oh, there should be. Sorry. Here, try this one. Okay, so everybody seems to have gotten 21, so we can try this one. Okay, so then it'll be 2 times 3 plus 3 to the power of 2 plus 9 minus 5 plus 8 divided by 4, which is equal to 6 plus 9 plus 4 plus 2, which is 15 plus 6, so it's equal to 21. Yes. Okay. Okay. So let's go on to the next question. Okay, so most people in the chat seem to have gotten 12, so let's just try this. Okay, so this will be, we're subtracting this expression, or here it says we're subtracting this one from this one, right? Because this is basically an element and this is an element. If we go back to thinking of it when we were using the CAR and CDR functions, so then it will be 2 plus 5 times 2 plus 3 minus 9 divided by 3 to the power of 1. Are there any questions on how I got this expression? No questions? Okay. Why is it plus 3? Because here we have 3, going back to our CDR, we have 3 elements in this list. And then we're adding all 3 of these elements together. Do you understand that better now? Yeah, okay, good. So let's continue to evaluate this. So then it'll be 2 plus 10 plus 3 minus 9 divided by 3, which is equal to 15 minus 3, which is equal to 12. So that should be the final answer, which is what most people seem to have got. Okay, so that is all for today. Thank you for coming. Okay, bye. You're welcome, bye.
Goodbye. Bye.